L be a language, then which of the following denotes the clean closure of L, that is L star. So here usually the clean closure denotes the 0 or more instances of any language. So here option A, L star is equal to union of I stars from 0 to infinity. Here it is 0 to infinity L power I. Option B is L star is equal to union of I stars from 1 to infinity L power I. Option C is L star is equal to L plus. Option D is none. So here usually, for example, if you take A is a language, A star denotes epsilon, A, something like this. So 0 or more instances. That means I starts with 0 and the union of all these things. Option A is the correct option here.
Question: 4 statements are given as 4 options, and we need to identify the correct statement. And if we observe option C, it is one of the properties of a simple graph, and it states that the number of vertices of odd degree in a simple graph is always even. So option C is the correct option.
Here it is given that if A is an n by n matrix and A is diagonalizable, then A has. Now, if any matrix, say A, is of order n by n, and if it is a diagonalizable matrix, then it will have n linearly independent eigenvectors. Now, option A is correct.
P, Q and R are open statements, and a compound statement is given. We have to negate that compound statement. Whenever we negate a compound statement, for all x will become there exists x, and there exists x will become for all x, and become or become and. So if we negate the given statement, which is negation of there exists x belongs to W, so if we negate this, we will be getting as for all x belongs to W, P of x will become negation of P of x, or will become and negation, and Q of x will become negation of Q of x. Here and will become or, and R of x will become negation of R of x. So from the given options, option B is the correct option.
Consider the following string S is equal to Canada, then which of the following is true? So Canada contain CANADA. So the options given are CAN is the suffix of S, B is CAN is prefix of S, C ADA is a prefix of S, and D ANA is a suffix of S. So here prefix means the set of all leading symbols, the suffix means set of all trailing symbols. So here CAN is given as a suffix, that is wrong because it is a prefix. CAN is the leading symbol. Option B is given as CAN is a prefix of S, so option B is correct. Option C, ADA is a prefix of S. ADA is a suffix actually, so it is given as a prefix, this is also wrong. ANA is a suffix. ANA is neither prefix nor suffix, it is a substring, so it is also wrong. Option B is the correct option. What is the decimal value represented by the following bit patterns? So some bit pattern is given, that is 11001, which is given in 2's complement. We need to find out the decimal value of that. The solution for that will be like this. So actually if it is 2's complement means usually we represent negative numbers in the 2's complement format. So the leftmost bit indicates a sign, that is minus. So that is the leftmost bit is -1 into, we represent like 2 power 4 because it's the fourth position, 0, 1, 2, 3 and 4, plus -1 into 2 power 4 plus 1 into 2 power 3 plus 1 into 2 power 0, because the first term and second term both are zeros. So it is equivalent to -16. 2 power 4 means 16 into -1, it is -16 plus 9, because 8 plus 1 is 9, it is equal to -7. So option D is the correct option here. Either we can do like this, or we can convert the 2's complement into original format just by excluding the sign, and that equivalent decimal value also we can find out. So this is the direct way of finding this. -7 is the correct option here. Option D is the correct. Is the largest natural number that can be represented in a 10-digit radix 3 number system. So radix 3 number system means base 3. So base 3, the numbers we can have is 0, 1, 2. So largest 10 digit number is 10 twos, 10 continuous twos. So what is the largest 3 decimal digit? 3 nines, something like that. 3 digit it is. So similarly, the maximum number in a radix 3 is 2. That is 2 should be represented a string of 10 twos. The value in the decimal we have to find out. So there is a formula for this. So here radix and then number of digits. What is the radix? 3. So 3 power, the number of digit is 10 minus 1. So 3 power 10 minus 1 is the value. So that is r power k minus 1, where k indicates the number of digits, r is the radix, or we can say base. So 3 power 10 minus 1 is equal to 59048. So 59048. Option C is correct. Option C is the correct option. Which of the following is true? Option A, LRU page replacement policy is based on principle of spatial locality. Option B, LRU is based on temporal locality principle of temporal locality. Option C is, in a virtual memory system with paging, you cannot run a program whose size is larger than the size of main memory. Option D, if a virtual memory page number X generates a miss in the TLB, then the corresponding page number for X is guaranteed to be found in the page table entry. So these are the 4 options. So in the first option, LRU page replacement policy is based on principle of spatial locality. So it is not based on spatial locality. It is based on principle of temporal locality, because the least recently used means we are going to replace the page that has not been used from the longest time period. So most recently used page we don't replace, we are going to replace the least recently used page. That means here it is not based on the future reference, it is based on the past reference. So that's why it is based on temporal locality. Option B is correct. So in option C is saying that in a virtual memory system with paging, you cannot run a program whose size is larger than the main memory. So it is, virtual memory system is meant for that only, because if you want to execute a program whose size is more than the memory size, then virtual memory is required definitely. That's why option C is wrong. Option D, in a virtual memory, if the page number X, virtual page number is X, generates a miss in the TLB. For example, there is no entry in the translation look asset buffer. Usually we search in the page table. So that page number need not be always find in the page table, because sometimes all the entries of the pages may not be there in the page table. Some references may be valid references, some references may be invalid references. That's why option D is also wrong. So option B is the correct option here.
Now the given recurrence relation is T of n is equals to T of n minus 1 plus 2n minus 1, whereas T of 0 is given as 0. Now let us first find T of 1, which is T of 0 plus 1, that is nothing but 0 plus 1, which is 1. Now similarly, let us find T of 2, which is nothing but T of 1 plus 3, which is nothing but 4. Now let us consider T of 3 also, which will be T of 2 plus 2 into 3 minus 1, that is nothing but 4 plus 5, 9. Now clearly we can see that T of 1 is nothing but 1 square, T of 2 is nothing but 2 square, whereas T of 3 is nothing but 3 square. So similarly, it is nothing but T of n is equals to n square. Now what do we need? We have to find T of 25, which will be 25 square, that is 6.